Hi, it's Kyle here with Cisco with Kyle, and we're going to go over what are VLANs using the Boson NetSim simulator. We're going to be highlighting kind of what are VLANs at kind of the intro level. The great thing about Cisco with Kyle is we're going to be just going over really the really high level of VLANs, kind of how they work, what are they, and kind of the commands. NetSim Simulator from Boson is a simulator tool that I'm using to prepare myself for the Cisco exam, primarily the 200-301 exam. It's essentially the first exam of the CCNA entrance exam. Using this tool, we're able to configure essentially this network that we see here. So in this little lab, you can see a router connected to a switch connected to two PCs. So essentially, if we had the reason why we use VLANs, let's go into an intro, and this is not scripted whatsoever. Essentially, the reason why we use VLANs is to create different networks inside one network. So in this little lab topology, we just have two PCs. And if these two PCs are communicating with each other, let's say we throw in a printer as well. So we have a printer and two PCs, and they're communicating back and forth, sending packets through the network to each other, and then going out to the network. This is their default gateway, this router one here. Then there wouldn't be much problems. There wouldn't be much bandwidth being used, and everything would be hunky-dory. But let's say the organization grows and expands, and from this access switch here, the switch number 1 here, this is a layer 2 switch. This layer 2 switch is then essentially giving access to all the endpoints that are all these PCs here. So this company grows from 2 PCs to, let's say, 100 PCs. These 100 PCs are now all communicating on one switch. Then they're accessing the internet to the outside network through router 1. Now, what would start happening is people would be starting to report lag. They would start reporting, things are slow. They're having to wait. Things are buffering. And what that means is that the network is just there's just too much on the network for the equipment to handle all the packets. So that's where VLANs come in. VLANs is like a virtual LAN. A LAN itself, if we take out the V, a LAN is essentially just an internal network. The V stands for virtual. And so what we're going to do in this lab is we're going to create kind of like now I haven't read this anywhere, but this is how I think of it, is like a channel or a group. And essentially, if you can group certain IP addresses into a group, let's say marketing or sales, HR, into 3 of those different groups, then you've segmented that one network into 3 groups. And so essentially by doing that, you're going to then create a lot less congestion on the network. It creates less packets going back and forth in that one major network, and now you're segmenting it in 3. So that's kind of like good housekeeping, is to create VLANs to segment your traffic. But then also, that's not covered in this video, is security. Security by creating VLANs in different groups allows you to reduce your footprint and increase security as well. So in this lab with NetBoson in their Net Simulator, they give us all the commands that we need to kind of set up the VLANs. Essentially, the VLANs you can have as many VLANs as you want, and then we're going to go through it. So what I plan to do is just go through the instructions for this lab and kind of go over any kind of questions that I had that I'll answer that maybe you have as well coming to VLANs. So some of these first commands That's what I like about these lab instructions is that they come with all the commands that you need in the lab, so you don't have to be Googling it. And then you have all the IP addresses that need to be going on inside the interfaces. So here's the lab tasks. And so essentially what's this say, what this is saying is in the lab task here is essentially provide the IP addresses, configure the IP addresses on the router, you know, do the no shutdown, and the PC1, PC2, make sure they have the right IP addresses. So I've done that. So what we do there is we go show IP interface brief, show IP interface brief. I'm just hitting tab to auto complete the words because sometimes I spell them incorrectly, and two, it's faster. So I'm hitting tab when I'm typing out the word. Halfway through, I hit the tab to autocomplete. So as you can see, fast Ethernet. We only have in our topology here. We have this router, and this router essentially has one interface, and we can see that this fast interface is up. The protocol is up, and it's we set it up manually, and the IP address is here. And so that IP address was given in the lab instructions here, router 1. And essentially all you do for that is you got to go into global configuration mode, so, and then you're going to go IP address and then tab IP. Sometimes you can go question mark. Oh, so we're in global configuration mode, so we have to go exit IP. That's not going to work. So yeah, you do have to go into global configuration mode. So you go config T, and then you go see if you see this list here. IP address. IP address. Oh, I didn't know I need to do that. Oh, because you know why this is not doing it is because we're not in an interface. So we looked at which interfaces. If we make this bigger. Let's see, this is Cisco with Kyle, right? Just seeing what the problem is and fixing it. So we could see that it's the interface that's up is fast Ethernet 00. So we're gonna have to go into that interface and assign the IP address. So we go interface fast Ethernet 0/0, and then from there we go IP. See, now it works. And so now we put in. Come on, how do I make this smaller? There we go. So now we put in that IP address 2.4.2.1, and you got to put in the subnet mask. That's essentially how you do it. Back to the lab instructions here. So that's how you assign IP addresses onto an interface. The PC was kind of interesting. Excuse me. Using if you've used Packet Tracer, you actually go through a graphical interface. Yeah, so if you've used Packet Tracer, you can use a graphical interface to assign the IP address. But here, essentially, what we're using is IP config. So the instructions here are IP. Let's see here. Yeah, IP config /DG. That means domain gateway. And then ipconfig is /IP. So you got to do those two to essentially get these settings. So the computer knows its IP address, its subnet mask, and then default gateway. And to double check the latest, what you always have, you always want to do that, go ipconfig /all. There you go. So you got those things here. What a default gateway is essentially is if the computer is trying to connect to someone on the network, it's going to send out a packet, like an ARP, and that ARP sends out a broadcast saying, "Hey, I'm looking for this PC." If it finds it, the other PC will say, "Okay, hey, I'm here." That's perfect. But if it is trying to access something that the PC has discovered from other devices that it's not on the network, it then hits up the default gateway and it says, "Hey, this isn't on the network. I need you to find this IP address." And then so the default gateway, essentially, if we go to the lab topology here, so the router is 99% of the time the default gateway because it's the edge router that's connected to the rest of the outside world. That's what you're paying your service provider to be, is the outside world. So your router, aka the default gateway, essentially is then what then retrieves back what you're looking for. So those are the kind of the three things that essentially a PC needs to be able to communicate to other devices on the network and getting outside the network. Yeah. What's next? So the next here, we've got to start pinging. So pinging on PC2 to PC1. So ping is essentially, it's a ping. So it's essentially using the TCP IP stack. That's using essentially sending out a packet. So if we see here, so ping from PC1, ping the router. Okay, so it wants us to ping the router. So essentially, we're seeing if this, see, it says a reply. So it's sending out 4 packets, and then there is 5 replies coming back. And so as you can see here, it's all successful. If for example, you hit a typo and it's like this, it comes back negative, like unreachable, request timeout, that means that there's nothing there, or the device that does have this IP address, maybe the interface isn't up yet. And that would say, not reachable. So those are kind of the things. So pinging is a way to test, if you do have a problem, to diagnose what the problem is. And that's a great way to determine what the problem is. So pinging is quite a popular thing for both new and experienced network engineers. Is a simple ping technique. So the next is setting up the VLAN. So again, you're setting up virtual kind of groups. And this is a real simple one. In this lab, we're just creating one VLAN. Now, if we go back to the switch, we go show VLAN brief, you can see that I've already kind of set this up, but essentially all of these 3 interfaces that are used, the FA12 is what's being connected up to the router, and FA Fast Ethernet 01 and 02 are going to the PCs. And essentially what I've done in this lab is I've put them all on the VLAN 22. But when you first work with this lab, you'll see that all of the interfaces are actually all in the default VLAN 1. And so if you hooked up, if we go back to this lab topology here, so if you switched up the PC1, the PC2 to the switch, to the router, they would all, take 30 to 60 seconds to create its adjacencies. And then once they've created their adjacencies, they're, for example, the PC in 1 and 2 have added itself to the cam table inside the switch. And so the uh, the next thing is that they're all going to be able to ping each other because they're all on the same VLAN 1. The lab instructions then start telling you, hey, start putting the PCs on VLAN 22. And so you'll put the first PC one on here, and I'll show you the instructions on how to do that. PC one onto VLAN 2, and then it says, hey, ping the router. And so, of course, you ping the router, and you start getting unsuccessful pings. And the reason why that is because the two devices, the router and the PC, are on two different VLANs. And the only way you can get all of them to speak with each other after you update all of them with VLANs up to VLAN 22, they'll then start communicating with each other. Now, not in this lab, but probably in the next lab, what happens if you have more than one VLAN? So if you have, a VLAN for sales, a VLAN for HR, or a VLAN for marketing, essentially what would happen is in those different branches of the company, you would have the router as being the head decision maker. So all packets that are being tagged with a VLAN number, they would all come up to router 1 and then be distributed back down to where it's trying to meet to its final destination. So a router is called encapsulation, 1Q, and we'll be going over that in a separate video. So let's go back to setting up VLANs. So in the lab instructions, it says here on switch, let's see here. On switch run review port assignments, which port should you add VLAN 22? Allow all devices to ping with each other. So essentially what you do is you find out on the switch which ports should be VLAN 22. And so we'll go into global. So whenever you're making changes on the device, you have to go into global configuration mode. If you do want to just see reports and stuff and see stats, you got to back out of it. If you do stay in global config and do want to see stats, you have to put in the word do. So let's go to global configuration mode. That's conf T short. And now that we're in here, we can then, so here it's saying assign the port for the VLAN. So I already know from previous, I know that my interface fast 0net 12 is up and it's connected, and that's connected to the router. So that's this guy here. So where you see my cursor, that's fast Ethernet 0 to 12. So what we're going to do is we're going to add that to the VLAN 22. So what we do is, because I've already done it before, I'm going to go into the interface, fast Ethernet 12, /12. Let's see if that works. Yes, it does. Now we're going to go to switch port. You're wondering what I'm going to type in here. I'm not making this stuff up. It's right here. So switch port. See, I can hit tab and it autocomplete. Switch a port, access VLAN 22, and then you go switch port mode. I think because this is going to be a router, okay, see, it's got a typo, right? So that's why it can show me what options I have. So switch port mode, and then I hit question mark and I see the options I have. And so this is going to be a trunk. Oh, okay, sweet. Okay, so you're probably saying, hey, Kyle, What is the difference between an access port and a trunk port? Okay, so a switch port, a switch port is essentially when a switch is connected to an end device. So there's just one VLAN being that's going through this red line here, same as this red line here. But as you can see, there's point to point here between the switch and the router. And so that's what's called a trunk. A trunk is something that's going to have more than one VLAN on it. So VLAN 22, VLAN 33, VLAN 100, VLAN 1000. And so there's going to be all these packets that are going through this interface, and they need to be tagged. Well, they are going to be tagged, and they need to go through this one red line. I'm calling it a red line just for simplicity's sake here, but through that cable. And so they're all going to be tagged, and they're all going to have different VLANs, and so they need to be able to go through that red line. So that's the difference between trunks and access. And so let's go over to now the setting it up for the interface. Let's back out of this. We go interface. We can go into a PC one now. Fast Ethernet 0/1, and we're going to go into, because we've done this before, I can just hit the up arrow and we can just add that. And then what we're doing is we're adding it to the VLAN 22, and we're adding it to port access because this is going to a PC. There's security reasons for why you put switch port mode access as well, so that if somebody took the PC out and switched it to a switch, replace the Ethernet cable out from a PC and switched it to a switch, it wouldn't work. So there's security reasons on why you do that as well. But what's next? I'm just going through the answers here now. So it seems like I've shown you pretty much all of it. I think what's a good example here is going to the switch here, just to cap things off here. Show interface status. So here you can see, here at the final conclusion, you can now see that all the active interfaces that are up on the switch, FA1, FA2, FA12 are up. And you can see that the 22 are access ports, those are the PCs. And then as you can see, the FA12 is a trunk. And so now if all the devices in this lab topology can now ping to each other. And that's about it. So hopefully that helped you about what VLANs are and how to configure VLANs on a simple little network. And that's it from Cisco with Kyle.